So I wanted to catch you up with some of the current goings on with the turoborocket engine development. I haven't posted since October. Been working on various things, including some support components for the turoborocket engine testing. So notably, what I'm going to show here is the new Switchbox configuration for the turoborocket engine testing. The way we do our testing is we have a lot of solenoid valves that drive and operate our system. This is the fuel valve. This is the oxidizer valve. We have the igniter, fuel and oxidizer, and then a purge, and then we also have a purge for the main system, for the main propellants, and we also operate the crank air valve, which is right here. We all operate those. Those are all 24-volt DC valves, and we control them manually using a Switchbox system. And we'd been using that for quite a while. It had worked very well. You may have seen it in some of the previous videos, but it kind of petered out, and it was kind of having troubles. Got a lot of use out of it, but it is finally we kind of wore it out. So I've designed and built a new Switchbox, which is this element here. It included some improvements over the previous box that make this a little bit easier to use, and so I just kind of wanted to show you this system. So this Switchbox uses these marine grade lighted switches as the main control valves for providing power to all of the valves. Unlike the previous valve box, these are direct connected. These are 20 amp, 24 volt switches. They're rated for quite a bit of current that you might use in various applications on your boat. They're also waterproof. So that was kind of a good feature about those. The whole system is powered by this power supply here. This is a switching power supply, regulated 110 volt line in, and then 24 volt DC out, rated up to 25 amps. So we're only going to, so I built the system to accommodate up to 9 valves. And so if you have 2 amps per valve, that's 2 amps per switch, that's a maximum of 18 amps at 24 volts. So this should be more than enough to accommodate full power to all the up to 9 valves if we need to. And our current testing, we're only going to be needing about 7 valves, so that's how many we'll be connecting up. But anyway, we just have that capability for the system. So the way it works is this regulated switching power supply. We just kind of plug that in, and you'll see it come on. So we'll plug it in here, and you'll see the power come on there. Okay, so our power is on there, and then we're going to use the power output. This is the specialty connection, waterproof connection, 24 volt up to 25 amp DC electrical power, and that plugs into the back of the box. So we'll plug that in back here, and in the back you can see the various connectors. These are the connectors that go to each of the valves, and then this is the power connector. So we'll go ahead and attach that. And when we attach this power, the power indicator light will come on, and you'll see that in a minute. So this is going to plug in. This is going to plug in right there, and then when we get power to the system, the switch box, the main power switch, which is this switch here, will show power. So I'm going to show that in just a second. Okay, so now we've added power to our system. We've plugged in our switching power supply here, and the power goes back to the back of the switch box. We've plugged that in. And so when the power supply is on, basically when it's plugged in, it indicates on the front panel the main power light that there is power to the system. And then we can activate the rest of the systems with the main power switch. So by turning this on, all of the other subsequent switches, which are in standby now, gives us an indication that we have power is available to that valve when it is switched on. And then when we switch it on, the green light on the top of these will come on, indicating that the valve is open or it has power to it. All of our valves are on the system are normally closed, which means that they stay closed even if power comes off of them, and then they, if power is added to them, they open. So that's our system. And then on the back, we have all the connections to each of the corresponding valves. So you can kind of see our connectors here. There's our power, but then we have the indicators for the these bulkhead connectors, panel mount connectors for each of the corresponding valves, 1 through 5 on the top, and then 6 through 9 on the lower level. I've connected up the first valve. This is line cord number 1, and you can kind of see that right there, the indicator number on the line. That's wire, connector cable number 1, and I've got it into port number 1. So these are all these connectors are M12 type connectors with terminal block type connectors on them. They're really great. I've really liked these particular types of connectors. They're robust, they're waterproof, and they're easy to put together. And they're not terribly expensive either. So this line goes to our valve. Again, we have a cable with a male and female on each corresponding end, and then we connect that to the valve. This is the valve. This is our new pneumatic valve. Well, it's solenoid valve, but it will be flowing air, which is the oxidizer in this testing. So this is a 24 volt, about half an amp valve, and so it's connected up with an M12 connector, and then we've plugged that in here. So now we have power when we activate the switch all the way to the valve. And so I'm going to cycle that valve, and you will hear the valve cycle, indicating that the system is working. So we can kind of see that here. Let's see if I can manage both the valve and that. So I'm going to turn the valve on. I don't know if you can hear that. The valve comes on, green light indicates there's power to the valve and it's open. And you can hear it on the valve here too. So that's our new valve box system, our new switch box system, sorry, control all the corresponding valves, and that will be using that for subsequent testing. So it was an interesting project. I got a lot out of putting the system together, but it took longer than I thought. I should also add that within the switch box, you can't really see it because it's buttoned up here, we have a Schottky diode for flyback voltage regulation. It just shunts any flyback voltage when you shut the valve off and protects some of the system. That's kind of baked in there into the system. So anyway, so that's our system. Power is off. And we'll depower the system by merely unplugging it. Little capacitance there, and that's about it. On to further testing.